Okay, well, welcome back to the wonderful world of quadratics. Today we're going to take a little visit to the imaginary kingdom. We're going to be looking at binomials with complex, which means imaginary, factors. Now, binomials, we've learned how to factor a binomial that has a perfect square minus a perfect square. We call that a difference of squares. We said what this will factor into is the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. And these factors, we called these conjugates. They had the same terms but opposite signs. And in fact, we learned how to factor a difference of squares where the second number was not a perfect square. This I could look at as a plus, well, what number squared is 3? Well, radical 3. So a plus radical 3, a minus radical 3. All right. Now, we said that if we have a sum of squares, though, we did not have a method for factoring this. Well, all that's going to change now, because we can rewrite this so that it is a difference of squares. I've got a squared plus 4, I can rewrite as a squared minus a negative. Now I've got a difference, a squared. Well, is negative 4 something squared? Well, yeah. Square root of negative 4 is 2i. So, negative 4 I can rewrite as 2i squared. So, this will factor into a plus 2i and a minus 2i. All right? Not too bad. Looking at something like this, I got 4x squared plus 9. Looks a little bit complicated. I can't factor out a greatest common factor, but I can view it as a difference of squares. I can write this as 4x squared minus a negative 9. And now I can factor 2x plus square root of negative 9 is 3i, and 2x minus 3i. All right, this isn't so complicated. One more here adds a little bit of another wrinkle to it. Again, I've got the sum of two terms, and I can rewrite that as minus a negative. Except, what is the square root of negative 8? Well, square root of negative 8, well, that's the square root 8 times the square root of negative 1. Radical 8, well, I can't find the square root of 8, but I can simplify that radical to 2 radical 2. And of course, the square root of negative 1 is I. So this is going to factor into x plus 2 radical 2i and x minus 2 radical 2i. Cool, cool? Now this is going to allow us, excuse me, to solve equations of the type 5x squared plus 10x, or plus 10, equals 0. Now, we could solve this by isolating the x squared, but factoring is another method that sometimes comes in handy. I can now, well, here, factor out the greatest common factor is 5. And again, now I've got x squared plus a number, but I'll view that as minus a negative 2. So I get x plus the square root of 2i, x minus the square root of 2i. And solving this, setting each factor equal to 0, I get x is equal to negative radical 2i, and x is equal to positive 2 radical 2i. Say that again. X is equal to positive radical 2i. Which I can write a little bit more succinctly as plus or minus radical 2i. Whew! Well, that's all I got for you tonight. So it was a short lesson, a little bit complex, but I think very understandable. We'll use this tomorrow to solve equations and to explore other quadratic functions that don't factor, that aren't binomials but are trinomials. But until then, I'll see you later.